Is it recording? Okay, right. It's recorded. Okay, please let me know as usual if you cannot hear me, or if you cannot see the slide, or if you cannot listen to the sound that I'm playing, right? Because don't type in the chat, because I cannot. I'm not reading the chat book while giving the lecture. The chat section while giving the lecture. So I would appreciate if you can unmute yourself and inform me of any issue, right? Okay, so like I mentioned, today's topic is on stormwater drainage or stormwater management. It's actually the same thing, right? It is actually referring to the same thing lah. It's about drainage, right? Drainage of stormwater. Okay, so as you can see from the icon there, right? So I just put the icon of rainwater, okay, so that it stick into your head. Right. So what is stormwater? Stormwater, sometimes we call it stormwater runoff. Okay. Or you can just call it stormwater. So, but it is actually referring to the rainfall, right? The rainfall that flows over the ground surface. Right? And then it is created when rain falls on road, driveway, parking lot, rooftop, and other paved surfaces that do not allow water to soak into the ground. So even though the definition is rainfall that flows over the ground surface, okay, but before it falls on the ground, it flows on the ground surface, it would fall under the on the roof, right? So it will fall under the roof, and in other places like overseas where there is snow, right? So that is also considered as, I mean, especially when the snow melts. So that is also considered as stormwater runoff, right? But of course, for this lecture, I'm going to give the context in Malaysia, right? So if you are from maybe the Arab nation or from Africa, so we are not talking about your place, unfortunately. Right? So what I'm going to tell you today is solely related to Malaysian context, right? Because especially in Malaysia, we have a lot of rainfall, okay, annual rainfall. So the system might be different from other places. So stormwater runoff is the #1 cause of stream impairment in urban areas. Okay, so because of the heavy rainfall, okay, I believe you have heard about what do you call it? Flash flood. Okay, flash flood, because whenever we have stormwater, okay, especially if it is a heavy one in KL or in urban areas, especially in Malaysia, it would cause a flash flood. And if there is no proper management of stormwater, then it would actually disturb, or it would actually cause pollution to the river, and then it would cause a lot of trouble, a lot of problem to the urban areas. Okay, if let's say the flood is not channeled to the right path. So because of that, development require a stormwater management or drainage system to ensure that stormwater runoff is properly channeled to its last point of collection. Okay, so we can't expect the stormwater to just dissipate, or to just be absorbed into the ground naturally. Okay, so that's why in the development we need to provide proper management system or drainage system to channel the rainwater, to channel the stormwater to the last point of collection, which is normally the river, right? Because if not, then that would cause a major flood in the area. Okay, instead of flash flood, we call it flash flood because it happens in a flash. Okay, it happens very fast, so that's why you call it flash flood. But if you don't deal with the flood itself, then it would become a major flood, and it won't go off very fast. It would take time to go off. So that's why it's very important to provide stormwater management and drainage system. Okay, poor management system will result in many related environmental issues such as erosion, flooding, and pollution. Okay, so as you know, I believe you have seen pictures on TVs, you have seen videos, you have seen clips on the news, right? What happened during the flood? Okay, so it would carry all the garbage, okay, mud, everything with it. So that's why it would cause a lot of issues, basically, right? And then in areas where, especially in hilly areas, right? Areas with hills development near the hillside. So if we don't treat the stormwater runoff carefully, then it would cause erosion to the land. So when erosion happen, then I think the most critical issue would be loss of life. No? So when the erosion happen, right, it would maybe the soil would hit the building, everything, and then it would cause a building to collapse. Okay, so that's why it's very important. Okay, so as you can see from the image down there, right? So to simply describe what stormwater runoff, especially on building, right? Because as an architect, you're dealing with buildings, not so much about other things. Because actually, this topic relates to there are 3 areas that I'm going to show afterwards. So the first area deals directly with your job scope as an architect. And then the second and third is not so much related, and actually the content also not too heavy on that, and it actually relates to civil engineers. But of course, as an architect, you need to know everything. So you need to know where the stormwater from your building is channeled to, right, from the starting point until the last point of collection. So as you can see from the image, you can see that so those are the runoff related to a building. So runoff from yards, okay, because the rainwater fall directly to the yard. So it also need to be channeled correctly, okay, to the intake point, to the inlet point. And then the major one would be run off from the roof, okay. So it has to be collected, yeah, and then channeled properly to the drainage system. And then runoff from driveways and streets. Okay. So apart from the runoff inside your building compound, inside on the roof and on the yard, so the water is actually coming from the driveway and from the streets. Okay. So they have different component to deal with now, right? So to collect rainwater from the roof, so we have different component to collect runoff from the driveway and street. So we have different component, and then runoff from yard. So there is a different component that deals with the runoff. Okay, so if let's say the stormwater is not managed properly, okay, we just look at the house lah. So we just look at the at the building context, right? So don't talk about like public places like the streets or the public park or something. So even if we don't treat the stormwater from inside the building, it would carry with it a lot of pollutants, right? Bottles, you can see the bottles, and then maybe some oils from, I don't know, probably your car, right? So what the what lubricant actually dripping from your car. So and then when the stormwater runoff actually flush away the oil, okay, into the ground. And then maybe if you have a dog, then your dog poop, right? And then the stormwater carries away the dog poop as well. So things like that. So in the end, it would cause pollution, okay, to the ground and then to the environment. Okay, so this is the one that I'm talking about just now. So there are 3 parts of stormwater management, right? And then each parts or each section has their own component, right, for the system. So the first one is property drainage. So property drainage deals with whatever drainage system inside the building property. So it doesn't matter whether it's a house, it's the building that you're designing now, a community center, or whatever kind of building. So there would be some kind of drainage system need to be installed on the property. Okay, so the the usual ones would be gutters, RWDP. I think I believe you have heard about this term, RWDP, or rainwater downpipe, as well as the drain. Okay, so I just intentionally put the drain in between property drainage and minor drainage system because the drain actually carries the stormwater runoff from the building into the minor drainage system. Okay, so in a way it's in the middle, so because the drain is actually located around the building perimeter as well as the building line, okay, outside the building line. Then the second one is minor drainage system. So we have street gutters, inlets, pipes, and open drain. But as I mentioned, the number 2 and number 3 is basically is under the care of a civil engineer, right? So as an architect, you don't really have to worry about that. You only need to worry about the property drainage. But even though it looks quite simple, but as a good architect, you need to master this topic. And then finally, the major drainage system, which consists of trunk drain, pipe networks, monsoon drain. So you can see there are a lot of different kind of drain, right? So the first one is drain, which is like the simplest one. Actually, they are all can be considered as open drain. Okay, especially in Malaysian context, we use a lot of open drain. Okay, they are all open drain actually, but the sizes of the drain differentiates between all the three, the drain used in all the three parts. No? So the drain used in property drainage is, of course, the shallowest. Okay, the shallowest and the most the smallest, I would say, right? And then the one that we use in minor drainage system, open drain, is slightly bigger than the drain that we use in the property. And then finally, in the major drainage system, we have trunk drain is bigger than the open drain, and monsoon drain is, I would say, the biggest, right? So the storm water actually flows from beginning from the property, okay, from the gutters of the roof into the drain, into the open drain, to the trunk drain, to the monsoon drain, and finally into the river. Okay, so basically that's how it flows. Okay, so now let's look at the first one, which is property drainage. And I hope that you really pay attention to this topic because not only for the assignment that that you are doing for building services, that is secondary. Okay, the primary reason you need to learn about this is because it relates so much to your design, right? Because if not, then your building is going to be just like any other building. Okay, especially when it comes to the drainage system. Okay. All right. So property drainage system consists of the following components. The main components are gutters. Okay, gutters, rainwater downpipe, and the drain. So as you can see from the image down there, basically that the image shows the property drainage until the minor drainage system. So because you can see the street drain. Street drain is basically just the drain located just on the side of the street. Okay, and then you can see a lot of components, right? Box gutter, eaves gutter, downpipe, valley gutter, eaves, and then the pit pipe, right? Inter-allotment drain, sump and internal downpipe. Okay, so those are like this minor component. I mean, part of these three main components now, which I'm going to explain afterwards. And from the image also you can see the type of gutter, right? The type of system used for different kind of roof. So you can see from the image there are two different kind of roof. So the first one is just a simple pitch roof. Okay, so simple pitch roof. So normally the gutter system used in the pitch roof is eaves gutter and valley gutter, and then for industrial building or in modern building where you normally use like a mono pitch roof, sometimes you use like butterfly roof. Okay, but unfortunately it's not showing any flat roof. Okay, because actually in Malaysia we kind of discourage the use of flat roof, right? So if if possible, try to keep it to a minimum, right? Because of the very high annual rainfall that we have. Then flat roof is actually not really a good option, okay, to put on your building, because if you have a flat roof, then there will be a lot of issues actually with what maybe the waterproofing system, if it is not applied carefully, okay, then the water would drip into the space below. Okay, so what is shown here is basically just the pitch roof as well as the sawtooth roof applied in the industry. Okay, so if you are not aware of the name of the roof, it is actually called sawtooth roof, especially for industrial building. Okay, the first component for property drainage is are gutters, right? So I believe you know what gutter is, right? So it's actually a channel. A channel is actually something like a drain. So on the ground you can call it a drain. Sometimes it's also called channel on the ground, but it actually refers to the same thing. It's a drain, right? But it's just that when we apply the drain on the roof, we call it gutter. So even sometime on the road, if we apply we apply it on the ground, so we can call it gutter, right? Street gutter, for example. But it's actually located, it's actually placed on the ground, right? So in a way, gutter is actually referring to a shallow, a very shallow drain, right? But for roof, the most appropriate term is, of course, gutters. So it's actually a channel at the lower edge of a roof. You don't put gutter at the top of the roof, eh? Okay, so that's basically is the ridge, the top of the roof, especially when we talk about a pitch roof. Okay, the top of the roof is called a ridge, right? Where the two side of the roof meets on top. So that's the ridge. We don't put gutter on the ridge, right? I believe you. I mean that's a common sense, lah. So it is placed at the lower edge of a roof that collects and carries away rain. So it doesn't matter what kind of roof that you have in your building, you always put the gutter at the lowest, at the lower edge of the roof. So if it's a butterfly roof, then it's actually between two roofs. So you need to put the gutter in between the two roofs, because we have two edges of the roof, right? Pointing to the same direction. So you need to place it there. Even if it's a flat roof, actually there's some kind of gutter that need to be used to collect the rainwater, and it is also placed at the lower edge of the roof, right? Because it actually flows with gravity, so the water flows with gravity. So that's why we have to put it at the lower edge of the roof. So the purpose or the function of the gutter is it diverts the rain, usually to rainwater downpipe, as you can see from the image. There are a few other ways actually, but which I'm going to show afterwards. But I believe the most common component used with gutter is the rainwater downpipe. Okay, so from the gutter, the stormwater would be channeled, okay, would be diverted to the rainwater downpipe, and then it is conveyed to a drainage system on or below the ground. Okay, especially in Malaysia, like what I mentioned earlier. So I'm talking about Malaysian context. So from the gutter, it flows into the rainwater downpipe, and then from the rainwater downpipe, it flows into the drain, the perimeter drain around your building. Okay, it depends lah. I mean, in some cases, the water can be diverted right into the inter-allotment drain, which is the bigger drain outside your building property. Okay, but it depends on the location of your building. Okay, this protect the exterior surfaces of the building and its foundation from them and potentially suffering damage. So if the water is not channeled properly, okay, so if you allow the water to accumulate and to be stagnant in one place, then it would cause dampness, okay, to that particular part of the building. Okay, so let's say if let's say we're talking about flat roof, then if you don't channel the rainwater on the flat roof carefully, then it would accumulate. It would actually there's a term used for it. It's like water ponding. If you have heard about the term, okay, you allow the water to pond in the middle of the roof, then it would cause dampness to that below the roof, and then as it damps, then it would cause mold, mildews below the roof, right? And then because of that, it would cause damage. It might potentially cause some damage. The water might actually flows into the crack of the roof, and then affecting the maybe the wiring system inside the roof. So things like that. So that's why it has to be channeled quickly, okay, and carefully to the drainage system. So adequate provision should be made for rainwater to be carried from the roof of buildings. Right? But actually, there is a calculation method, okay, to determine the size of gutter, to determine the size of the downpipe, the number of downpipe. But it's actually quite complicated, lah. You know, I would say, because I think we require I mean, maybe another session to just deal with the calculation. But actually, in the industry, basically, when it comes to gutter, downpipe, everything, even though, like I mentioned, as an architect, you have the power, right, to control or to design the stormwater management. But of course, the parts, the gutter parts, downpipe, everything would be supplied by a specialist, right? So they would advise you on the right sizing, everything. Okay, but of course, for the initial design, you need to have some idea. So because of that, in your design, basically, you cannot have very little downpipe. For example, you have a very huge roof that covers the whole building, and you only have one downpipe. Okay, so that is not logical. So you need to provide several, maybe 3 on each side. You have 3 downpipe, right? So 3 goes to the back and 3 goes to the front, or something like that. Okay, so when you talk about gutters, there are 3 main type of gutters, which is eaves gutter, valley gutter, and also pad or box gutter. So let's look at the difference. The first one is eaves gutter. So eaves gutter is basically the most common one, the most common that you can see in a building, right? Even as I'm talking right now, I'm looking at my neighbor's house in front, so I can see the gutter. And even in your house also, I believe every day you are looking at the gutter, right? Maybe intentionally or unintentionally. Okay, but it's everywhere actually, especially in Malaysia. But of course, there are also some houses which is not equipped with gutter, but at least they have the drain on the ground, right? So if there's no gutter, at least you need to provide a drain on the ground. So eaves gutter is a gutter fixed at the edge of a pitch roof to convey water away from the eaves drip. Right. So when we talk about eaves gutter, it relates to automatically it relates to pitch roof. Okay, because when you have pitch roof, then you have the roof eaves. Okay, you have the roof eaves at the lower end, and then the top end, like I mentioned, you have the ridge. So when you have the roof pitch, the eaves at the end, so you need to use eaves gutter. Okay, so yeah, the purpose is the same lah, to basically to convey water. But in this case, it carries water, it conveys water away from the eaves drip. The eaves drip is basically the furthest end of the roof tiles lah, basically. So you just imagine if you don't have the gutter. So basically the roof tile is actually protruding a bit from the fascia board. Okay, so I believe you understand, right, what I'm talking about, because you have learned building construction and everything. So I hope you remember the different parts of the roof. Okay, so wait, let me point it here. All right. So basically this is the fascia board lah. Right, as you can see, look at my pointer here. So this timber, or this piece here, is called the fascia board, right? And then the eaves gutter is actually attached to the fascia board. So just imagine that if you remove this gutter, okay, so the eaves drip is actually, this is the eaves, right? So basically water drips from the end of the eaves. So basically that's it. So the eaves gutter actually just carry the water from the roof, okay, that flows over the eave, over the roof eave, okay, and then channel it into the downpipe. Right. So it may be fixed to a fascia board or supported on simple metal brackets. So depending on the system, sometimes some building they don't have fascia board. So not necessarily all building need to have a fascia board. Okay, especially if, let's say, overseas. So a lot of building overseas, the roof, even though they use pitch roof, but they don't have the roof overhang. But in Malaysia, overhang is like something like this, right? So overhang. So because of the overhang, normally you have the fascia board. So that's why you connect the gutter you put the gutter at the fascia board. But some building there's no overhang like this. So the roof just stop here. Okay, just like just at the end of the wall. So because of that, the gutter is placed on the wall instead of on the fascia board. So when it is placed on the wall, then it has to be, it needs a bracket to hold the eave gutter. So it comes in different shapes, half round like this, okay, deep flow like this, square. Even though it is called square shape, right? But it is not really square, I would say. Okay, and then in ogee shape. Okay, actually this is the first time also I heard this term ogee shape, right? So I don't know what it means. But sometimes it is also called K, okay, K shape. Okay, but I don't know where the K shape comes from also. Right, so that doesn't matter. It depends on the supplier, because this component is supplied by the manufacturer, by supplier. So they might come up with a different shape, okay, of eave gutter, right? And then it depends on the client which shape that they prefer. And I believe as an architect, so you have a say on this, because I think a proper selection is very important, because it somehow complement your design. For example, like this one, this is the ogee shape I mentioned earlier. So this is quite nice to see from the front, right? Because it looks like cornice. Okay, it looks like a cornice to your building. So it doesn't really look like a gutter, but at a glance it looks like a cornice at the edge of the roof. which is quite nice. But of course, when you look at the rainwater downpipe, automatically you would know this is a roof gutter. So these are the fittings used in the eaves gutter. So basically, the gutter is not like one piece object where we have a lot of different parts in it. It is actually made of different fittings or different component. Okay, so the gutter itself is just this part here. Okay, the straight one here. But actually, there's also another component here, right in the middle. But the gutter itself is this thing. Okay, so it's open on both sides. Okay, so because of that, that's why there is a fitting. A fitting is needed to actually close off one side, especially if the gutter is placed at the end of the roof. Okay, it is connected. It's not connected to another gutter on a different side of the roof. So you need to close off, okay, with this capping at the end. And then in between the gutter, you would have this connection, okay, between the gutter and the downpipe. Right. As you can see from here, there are three different kind of connection. Okay, so if this is at the corner of the roof, the outer corner of the roof, you need to use this type, and the inner corner of the roof, so you need to use this type. Okay, they might be the same and they might be different, but this one is of course different from the corner joint. So this is when you have rainwater downpipe along the straight run of the gutter. Okay, so like I mentioned, you cannot have a very I mean, on one side of the roof you cannot have only one gutter, especially if the roof is big. So you need to have several outlet. Okay, so it could be one in the middle like this. Okay, one at the end like this. Okay, so but for this kind of fittings and components, they are actually related to the gutters that you can purchase from the supplier. Because there's there's a different kind of gutter, which is concrete gutter. So concrete gutter is different. So concrete gutter, there's no such component, right? And you cannot purchase concrete gutter on the store. So I'm going to explain about concrete gutter later on. But now let's look at the other type of gutter, which is valley gutter. So valley gutter is not really a gutter. It's actually maybe if you have heard the term flashing. Okay, so flashing is normally used between the roof, okay, the joints between the roof and the wall, for example. So you need to have like a piece of like a zinc or metal, okay, a piece of metal connected between the wall and the roof. So the purpose is actually not to allow water to seep in through the small opening of the joints. Okay, so the same goes to valley gutter. It's actually not really a gutter, but the purpose or the function of the valley gutter is the same as gutter. It's just that the component is different. So the component is different from the eaves gutter that I've shown earlier, because it is actually something like a metal plate fixed together between the two sides of the roof. Okay, as you can see from the image, is very slim, it's very thin, it's very slim, and then it is connected at the same level more or less with the roof. Okay, so the definition is a type of gutter fixed between two surfaces, typically between two roof pitches. Okay, as you can see from this image, these three images. So you have two different sides of the roof or the pitch of the roof. So one is going this way, one is going this way. So you need to provide the valley gutter. or between a roof to a wall that I mentioned earlier, to ensure that water can flow properly to the trough. Okay, so trough is actually referring to the it can refer to the gutter, or it can refer to the drain on the ground. Okay, so just to allow the water to flow properly into the gutter, like trough or gutter. So because if not, then just imagine. Okay, so the water from this side goes this way, and then from this side it goes this way, and they would actually clash between each other, and then most of the time the water would splash out of the roof, right, instead of into the gutter. So it would splash out, so it defeats the purpose of having the gutters, no? Okay, so that's why it's very important to have eave gutter, basically to collect, okay, before it fall into the gutter, the eave gutter, so it falls into the valley gutter. So from the valley gutter, it would be channeled to the gutter, to the eave gutter. So it is also known as valley flashing gutters, like I mentioned, because it's just a piece of thin metal sheet. Okay, it's a piece of thin metal sheet placed together between the two roof. So which is also known as flashing. Okay, so box gutter can also be used as valley gutter, because I haven't talked about box gutter, but box gutter looks more or less like this, the image on the left, bottom left. Okay, so this is box gutter actually, and because it is used between the two different pitches of the roof, two different sides of the roof, so it is also known as valley gutter. You can call it valley gutter or box gutter, but you cannot call this box gutter because this is definitely an eave gutter, but this is a box gutter which is used at the valley, valley between the two roof. I hope you understand what I'm talking about. Okay, the next one is parapet or box gutter. Okay, so a parapet or box gutter is a gutter at the intersection of a wall or a parapet wall and the bottom of a roof slope. So it depends on where you place the gutter. So if, let's say, your building has a parapet wall, so I hope you still remember what parapet wall is, okay, because that should be covered in building construction already. Probably you have forgotten, but actually parapet wall is a protrusion or extension of the wall. Okay, so instead of the wall is placed below the roof level, so it protrudes, it extends up a bit higher than the roof. Not to say roof level, is higher than the roof eave. So as you can see from this image, this is the roof eave, okay, and the wall is actually higher. So you can call that a parapet wall. Okay, so even though the name is wall, but it's not necessarily has to be constructed using brick or concrete. It can be something. It can be just like, especially industrial building, where the wall is constructed made of steel structure and then covered with metal deck, right? Metal wall. So that could be considered as parapet wall as well. So doesn't matter. As long as the wall is higher than the roof, then it is called parapet wall. And because of that, if you have a parapet wall, so the gutter that you use behind the parapet wall is called parapet gutter, right? So on the other hand, if, let's say, the roof connects to the wall like this, okay, it depends on design. Afterwards, I'm going to show some examples of the difference between the parapet wall and parapet gutter and the box gutter. For example, like earlier I've shown you the sawtooth roof. Okay, sawtooth roof is like you have a roof, you have the roof pitch on this side, and then you have a wall, and you have a roof again, you have a wall. So something like this. Okay, so you have a roof here, and then you have a wall, And then, of course, above the wall, you have another roof going to the back, or it can also flows to the front into the same box gutter. Okay, so in this case, so you have the roof here, and then you have the wall. So the roof does not connect directly to the wall, right? So there's no way the roof can connect directly to the wall, because if there is no gutter, then the water might flash, might splash. Sorry, might splash into the, because you can see the window opening here, right? So if there's no gutter, then the water might splash into the window and into the space behind this. So that's why a box gutter is provided here. Okay, so basically when the stormwater runoff flows on the roof, it will be collected in the box gutter. Then from the box gutter, it will be channeled through the downpipe, right? So box gutters shall discharge via a rain head or sump to a downpipe, right? So let's look at what rain head is and what a sump is. Okay, but eventually the water would flow into the rainwater downpipe as well. Okay. Again, this is the one similar, more or less similar to the previous image, where the box gutter is placed in between the roof eaves. Okay, at the valley connecting to roof eaves. No? So it is called box gutter, or you can call it eaves gutter, but it is more appropriate to be called a box gutter. Okay, box gutter shall discharge via a rain head or sump to a downpipe. So this is a sump is basically the lowest point, right? So it's like a pit, or it's like a slight drop. Okay, slight drop along the box gutter itself. Okay, so this, as you can see, this is the box gutter, and then at the edge of the, or towards the end of the box gutter, there's a slight drop, okay, to collect the rainwater. And then at the bottom of the drop, you can see there's a hole, right? A circle. There's a round hole in the middle of the drop, which actually connects to the downpipe. Okay, so basically below this, beneath the this sump here, basically there's a rainwater downpipe. Okay, to channel the water, the storm water out of the building. So same goes here. So this is the box gutter. Okay, and then here you can see the sump, and then at the bottom of the sump you can see the rainwater downpipe. And here, this is slightly different. So this is slightly different. As I believe in this roof, even though there's a box gutter and then there's a sump, but it does not discharge to the downpipe. But there is another component shown here, which I'm going to show afterwards. This is called a spout. Okay, sorry, it's not scupper. Yeah, it is called scupper. So basically, when the water fills the sump, it would overflow into the scupper, and then through, outside the building. So most probably at the ground level, there would be a drain to collect the rainwater. Okay, and this is what rain heads look like. Right? So basically, the rain head is placed outside of the roof. Outside of the wall. Right? So basically, the box gutter is inside here. Okay, within the building wall, inside the building wall. But the rain head is actually collecting water outside of the building wall. So basically, the box gutter, okay, will be channeled. Basically, there will be a hole, okay, made on the wall, so that the water from the box gutter would flow to the rain head, and then from the rain head, in this case, the black color one, I believe some of the water will be channeled to the downpipe, and some will be channeled through the spout here. Okay, so it would flow on the side. I don't know, probably it's just because of design effect or something. And if you look at all the rain heads, right? So you can see the same features. So the rain heads, then there's a hole on the side, Okay, so basically that's for overflow. So if too much water in the rain head, so it would overflows through the opening on the side, right? And yeah, beneath the drain head, normally there would be rainwater downpipe to channel the water through to the ground. Okay, so rain heads can become quite an interesting design feature of your building, right? But I believe I have not seen rain heads, especially in Malaysia. I don't know why. I don't know. Maybe there's no supplier, or maybe there are, but I've never, as far as I'm aware of, or as far as I'm concerned, I've never seen a drain head, especially in Malaysia. Okay, so normally in Malaysia, when you have a flat roof, okay, or if you have hidden gutter like this, because this gutter is actually hidden behind the roof, you cannot see the gutter. We don't normally see this thing, but usually I believe the system used in Malaysia is most likely is like this, using some and downpipe. All right, so this is these are examples of building facades with parapet or box cutter. So as you can see, they look very clean. They look very sleek. You don't see the gutter, right? And because of that, I believe some students, actually a lot of students, when it comes to the roof design, so that's why a lot of students they like to have flat roof, okay, in their design, because probably they are looking at this kind of facade, this kind of image of the building, okay, and they thought that it is actually using flat roof, concrete flat roof, which actually is not, or not necessarily has to be flat roof, okay, because when I was a student, during my time, we were banned from using flat roof, especially in undergraduate years. Right? We were banned from using flat roof in our design, so we need to use a kind of pitch roof or anything. You need to use roof trusses. Okay, so because of that, I would strongly encourage you to do the same for your design project. Okay, not for building services, but for your design, because there would be a lot of problems when using flat roof in your building. But you can actually achieve the same effect, the desired effect. So from the elevation, okay, from the facade, it looks like a flat roof. Okay, it looks exactly like a flat roof. You cannot tell whether it's a flat roof, it's a concrete flat roof, or it's a pitch roof, but it looks flat from the front. Okay, because it's actually because of the parapet wall. Okay, because the parapet wall extends up higher than the roof level, so you cannot see what's behind. You cannot see you cannot tell what kind of roof is being used in this building. But most of the time, when you have this kind of facade, behind the wall, behind the parapet wall is actually something like this. Okay, so you have a very mild pitch roof. Okay, the angle is very mild like this, but it is not concrete. It is not concrete, so it's using a metal. Okay, and then behind it you have a box cutter or parapet cutter, and but this one you can see the rain heads clearly, but the other images you don't see it because probably it's hidden. Okay, there is also a possibility that the rainwater downpipe is hidden inside the house. Okay, it's not shown on the outside, so the pipe is hidden inside the house. So that's why I mentioned earlier, before the lecture starts, you as an architect, you have the power. Okay? You have the power, you have the ability to control the appearance of your building. Okay, while using this drainage system. Right. So most probably for this one, the image on the bottom left, so the designer or the architect intentionally wants to use the rain heads and the downpipe as the feature of the building, right? Because it blends nicely. I would say it blends nicely, quite nicely with the building facade, right? Okay, so maybe for your project this year, okay, for your final project, if you haven't thought about your roof design yet, So maybe you can consider something like this. Okay, you can have a very sleek elevation, very sleek facade that looks like flat roof, but actually behind the wall you have a pitch roof. Okay, which is only shown in the section, can be shown in the section. Okay, so these are some examples of box gutter used in modern butterfly and sawtooth roof. Okay, so just to give you some inspiration, because I think most of the time as a student, you tend to design the roof as the last thing, right? The last thing that you consider in your design is the roof. Okay, because you spend so much time on the planning, okay, planning facade, everything, until you forgot about the roof. Okay, but actually the roof plays the most important, and it can be quite significant element. It can be quite significant feature of your building, of your design. Okay, so that's why you cannot treat roof design very lightly. You cannot simply if you don't know how to design the roof, you cannot simply put flat roof, concrete flat roof on the roof. Okay, so you need to start thinking about the roof design and incorporate it into your the overall appearance of the building, and then you also need to think about this gutter system. Okay, and how you can blend it with your design, the roof design. So these are some examples. As you can see here, the first one, the butterfly roof, and then in between the two pitches, you have box gutter, okay, to collect the rainwater. And I think this one is actually not using rain heads, even though it looks like a hole on the side. I believe the hole is just like overflow pipe or something, but the main the water is actually mainly channeled through the downpipe here. Okay, so it is kind of quite clever, because the downpipe is treated, or it looks like a steel structure, right? It looks like a column supporting the roof or supporting this box gutter, but actually it's just a rainwater downpipe, right? But using the like steel color, okay, metallic color, okay, painted on the rainwater downpipe, it looks like a steel column, which can be, yeah, people. I mean, especially if for normal people, right, or non-architect, if they look at this, they would think, oh, this it looks like steel column, doesn't look like a rainwater downpipe or anything. Okay, and the second one is here, the bottom left. This is also a butterfly roof. Okay, butterfly roof, but instead of using rainwater downpipe, I'm not sure if it's using rainwater downpipe or not. If it is using rainwater downpipe, most likely it is placed inside or behind this column over here, right? But I don't think it is utilizing rainwater downpipe, because it defeats the purpose of having this thing. Okay, so the purpose of doing this is actually basically the gutter is extended far from the building, right? And then the intention is actually to get like a the water feature effect. Okay, when the rain falls, the water would flow from this gutter, okay, to the ground. Okay, as you can see, the ground is quite dry, so I believe the water from the gutter would be channeled straight to the ground. Okay, so not into the downpipe or not into a drain or something, so straight away to the ground. But you can see how cleverly it was designed, okay, to blend with the. I mean, it is functional, okay, as much as it gives aesthetic appearance, aesthetic effect to the building, right? And then for the sawtooth roof on the right, yeah, you can have this kind of roof for your design. Doesn't matter, right? It's just that you need to know how to deal with it. Okay, of course, when you have this kind of roof for your design, you need to have box cutter to collect the rainwater in between the roof pitches like this. And in this case, this is the one that I mentioned. The rainwater downpipe is not exposed. Okay, it is somewhere inside the house, maybe just behind the wall here. So because there's a gutter here, the box gutter, and at the edge of the roof gutter, there will be a pit or a sump. Earlier I mentioned the sump, which would then channel the water to the downpipe. So most likely it's going to the downpipe is located either behind this wall or behind the other wall, or maybe there can be what they call it just now, the rain rain head. Sorry. So the rain head can be behind that wall because you cannot see it here. So most probably it's going to be behind that wall, but I believe most likely it's going to be hidden. Okay, the rainwater downpipe is hidden inside, so it's behind the wall. Okay, but yeah, as I mentioned, as you can see from these images, right? So the roof plays an important role in the appearance of the design. Okay, so it's one of the main feature of your design. Okay, people can see right from far away. Okay, they can notice your building just by looking at the roof. So that's why roof is very important, and you shouldn't treat roof design lightly. But of course, when you have good roof design, okay, you have a very nice roof design, so you need to deal with the rainwater. All right. So now you know how to deal with the rainwater. So I hope to see this kind of roof in your design, your final project. And finally, on the bottom right, okay, another example of a sawtooth roof, right? But this time, instead of the gutter is hidden behind the wall, it's hidden inside the building, so it is exposed, right? And then the water from the box gutter is collected through the rain head located here. So he also got a rain head, right? And I believe for this part here at the back here, there might be another component, because the rain head is not sure. Maybe just but also we cannot see an if gutter there. Okay, most likely the designer intended to just let the water flow from the roof, okay, to the ground. So maybe there's like underground drainage located here in between the two blocks. Okay, but what I wanted to show here is basically the rain head and the downpipe. And when you see this thing, right, straight away you can tell that behind this there will be a box cutter. Okay, logically also there should be a box cutter, even though if you don't see this, as long as the shape is like this, so as long as the pitch is inwards like this, right, there should be a gutter. Okay, especially box cutter, right? But if the roof pitch is outwards, okay, then you can tell whether it's using eaves gutter or not, right? You can see the gutter itself, but then and actually it's not really an issue like whether you have a gutter or not, as long as you have a drain on the ground. So doesn't matter whether you have a eaves gutter or not. But if your design, the roof design is like this, okay, it pointing inwards like this into, and then you have another wall or another roof going in different direction over there, then definitely you need to have a gutter inside, right? Okay, just now I mentioned about concrete gutter. Yeah, so now let's look into special kind of gutter, which is concrete. Okay, concrete gutter. So it can be concrete parapet gutter, or it can be concrete box gutter. But even though we call it gutter, gutter is like I mentioned earlier during at the beginning of this section. Gutter is actually just like a drain, a shallow drain or a channel. So it doesn't matter whether it comes in like I mean, whether you can buy it from the manufacturer, okay, mass produced by the manufacturer or otherwise. It is still called a gutter. Okay, but for concrete gutter, it is often built together with the building structure. such as beam, roof, and floor slab. Okay, as you can see from this detailed drawing here. Okay, so this is the wall. This is the parapet wall, right? This is the parapet wall, and then there's a beam here. So this is the beam. So the beam, and then this is the roof beam, which actually holds the roof structure. Okay, but as you can see, the gutter is actually built together with the building structure, which is in this case is the beams. Okay, in other example, for example, like this flat roof. This is a flat roof. Okay, so basically this gutter here, right, is built together underneath. Basically, there's a beam. Okay, there's a beam, and also the slab. So it's built together with the slab. So they cast together on site, okay, or in situ. So that's the difference between concrete gutter and previously the other gutter, because like the other gutter, basically you bring other materials, right? So you have completed the building structure, and then you bring in the gutter material or the gutter component, and then you install on the building. But for concrete gutter, you cannot do that, right? You cannot build concrete gutter in other place, and then you bring it to the site. So it doesn't work that way. Of course, I think nowadays, especially if you know, I believe you have learned about IBS, right? Industrialized building system. I'm not sure whether it's available in Malaysia or not. So one of the IBS component is actually precast gutter, okay, precast concrete gutter. So it comes in like in smaller sizes, and basically you just install on site. So it is manufactured in the factory, IBS factory, and then you just bring it to the site, and then you install on site. So just like other IBS component. But most of the time in non-conventional construction, the gutter, concrete gutter, is built together with the building structure, like I mentioned, beams or slab, the roof slab. It is most commonly found on concrete flat roof, balconies and terraces, and discharged through scupper or rainwater downpipe. Okay, so these are two examples of concrete gutter built on the flat roof, and another two examples are for gutter built on the balconies and terrace, right? Like this one. So basically, just like a slight drop. Okay, when we design the floor slab, okay, on when we construct the floor slab, so basically there's a slight drop on the floor, okay, which is the gutter, right, to collect the rainwater, everything, and then to channel it to. So similar to the box gutter earlier, so there would be like an opening that connects to the rainwater downpipe below. Okay, like this one you can see, right? But this one, because it's covered with the grating, so you cannot see the outlet. And scupper. So this is how scupper looks like, more or less. Okay, so scupper is just like an opening on the wall, like this. Okay, so instead of opening on the floor, because opening on the floor, it would channel the water to the downpipe. But when the opening is on the side, we call it scupper, and it is either, it can be connected to the rain head, like what I've shown earlier, or the water can be just discharged directly to the drain on the ground, right? So it depends. Okay, sectional drawing showing parapet and box gutter. Why I'm showing you this? Because I think at semester 5, even semester 4 or semester 3, we expect students to be able to produce this kind of sectional drawing. It might not, maybe not as detailed as I'm not sure, that it depends on your studio lecturer, okay, studio master. But I believe for your final submission, you are expected to produce a detailed sectional drawing like this. Okay, and if let's say you are utilizing the box gutter system, this kind of roof, okay, pitch roof that or sawtooth roof or butterfly roof, then in your section, by right, you should cut across your building to show the roof and the connection between the roof and what's happened between the two. If you are designing a butterfly roof, so what happened in between the two roof, it would be shown in this section. So here you can see on this side, there's a box cutter here, okay, box cutter, and then it is placed before the wall here. So you can see the wall here, and then before it doesn't connect directly to the wall, like I mentioned, because if you can connect directly to the wall, then the water might splash into the space behind the wall, right? And here, because there's a parapet wall here, so this is called a parapet wall, right? And the structure, but actually it is same thing. It's just the position actually differentiate whether you call it parapet gutter or box gutter. But actually they are all box gutter. It's just that when you have parapet wall, then you can call it parapet gutter. If not, then you just call it a normal box gutter. Okay, as you can see here, the box gutter behind the parapet wall is located above the roof structure. So this is the roof trusses, right? And the box cutter is actually located above the roof trusses, but below the roof finishes. Okay, it can be like metal deck or something. Same goes to this one, right? Okay, so I hope in your, this is not for, like I mentioned, this is not for the building services assignment, okay, but this is more for your design. So I hope to see this kind of detail, and yeah, I think it'll be quite interesting to see how you design your roof, right, after listening to this lecture. And then here you can see further detail. So this is the detail of the connection between the for the parapet gutter, right? So this is the one that I mentioned. The wall is made of steel instead of brick. This one is brick, right? But this one is made of steel. Okay, steel structure inside, and then cladding outside. Then you can see the gutter behind the wall, okay, behind the parapet wall, and then the gutter actually sits on top of this column here, and then this is the roof, the portal frame, okay, steel portal frame, okay, to support the roof finishes or roof structure. Okay, so another interesting feature, right, that you can actually incorporate into your design is this hidden box cutter. Okay, earlier I've shown you how to hide the gutter through a parapet wall. So you basically just extend the wall above the roof level, and then the gutter is actually behind, and all the pipes, everything is inside, so you cannot see the downpipe from the outside. You cannot even tell whether it's flat roof or a pitch roof by just looking at the facade. Okay, but this one is slightly different. Okay, but the construction is more or less like a parapet gutter. Okay, it's just that the wall is not extended, it's not protruded above the roof level. Okay, above the roof eave. So the wall is actually just at the side. It's just following the roof eave. Okay, so this is the roof pitch. Okay, so the wall actually just follow the roof eave, but the gutter is hidden behind the wall. Like this is the details. You can see this is the structure, steel structure. Then this is the wall, the cladding for the wall. This is the structure to hold the wall. This is the steel portal frame to support the roof. Okay, for the roof, and then this the structure for the roof, roof finishes, and the gutter is actually just here, right? So as you can see, you can compare between these two, the detail for parapet gutter and the hidden box gutter is actually more or less the same. It's just that what differentiates them is just the wall, right? One is with parapet wall. Okay, the wall is extended. This one, the wall is just finished at the same line as the roof, like this. Okay, but from the outside it looks very slick like this. Okay, very simple and slick like this. Okay, but it depends on your design as well. Okay, for example, like if let's say you're designing a building, I mean if there's no window, okay, especially in Malaysian context, even here you can see from this image there's no window on the side, then maybe it's okay to have this. But in Malaysian context, normally if you have window and then your roof overhang um, is not deep enough, okay, you don't have roof overhang, then water might splash into your window, things like that. So that's another thing that you need to consider lah. When if you want to use this, you need to consider that whether roof overhang is important for your design, okay, or for the site or not. Okay, scupper. This is I've mentioned about scupper earlier. Okay, a scupper is just an opening in a wall or a parapet that allows water to drain, just like that. Okay, so it's slightly different. It is slightly different from the rain heads. Earlier I've shown you rain heads, right? And then if you still remember the rain heads, you can see something like this, but it is connected to the downpipe, rainwater downpipe, right? But for scupper, there's no downpipe. So basically, this is the flat roof, right? And even like this image here, you don't see a gutter. You don't see there's no. You can see you don't see any like drain, any shallow drain behind the scupper. So it's just a flat roof. Okay, the floor is just flat, and then suddenly there are openings on the wall. So those are scupper. So meaning that the water is directly channeled through the scupper opening, right, and straight away into the onto the ground, or you might have like a drain around the building. So the water from the scupper is directly channeled to the drain on the ground, right? So this could be another design feature that you can incorporate into your design. But of course, yeah, knowing the amount of rain that we get in Malaysia, right? So the water that flows from the scupper might be, I mean, you can see that you can predict that the water might flow quite far from the building. So you need to design, or you need to place the drain carefully on the ground so that the water will be collected. If not, then the water might just fall onto the ground. It might flood the yard and everything. Okay, so it is commonly installed on roof, balconies, and terraces, like I've shown here. So this is example of scupper installed on the roof, and then this is scupper installed on the balcony, right? And this one, I'm not sure whether this is a roof or I'm not really sure what this is, but this could be another idea, right? One idea for a nice scupper design. So a scupper is different from a gutter, as gutter uses an actual piping system. Okay, as you can see, if you remember earlier, I mentioned that the gutter, you have like the fittings, gutter fittings, which is actually considered, it can be considered a pipe. So when we say piping, it doesn't really mean like a cylindrical pipe. So it's just like a channel to channel. The purpose is to channel water. So in this context, gutter also can be considered as a piping system. Okay, so basically the water would just flow, okay, at the end of the spout down the side of the building. Okay, these are some ideas for aesthetic scupper or gutter design. Right, more or less like earlier I've shown, like for the example of butterfly a gutter, a valley gutter used in the butterfly roof and sawtooth roof. So this one is basically just like this could be part of gutter or part of scupper. It depends lah. If let's say there's no gutter behind the roof here, then this is considered as a scupper. Okay, but if let's say this is like just an extension from the gutter, so meaning that this whole side here that there's a gutter right along the roof here, then this is considered a gutter, part of the gutter, the gutter spout. But if there's no gutter, then this is considered as scupper. Okay, so I hope you understand what's the difference between scupper and gutter. Okay, so this, as you can see from these images, right, just by using the gutter or scupper, okay, you can create an interesting design for your building, right? So yeah, just to give you some ideas. Hopefully you can apply, try to apply it to your design for this semester. So this is another one. So this is a butterfly roof, but of course this is like there's a gutter. You can see quite obviously there's a box gutter, okay, at the valley between the two roof here. So you have a box gutter, and then this is quite interesting how you design, because this box gutter is made of concrete. So you can actually form the gutter into certain shapes that as you wish. So in this case, the spout, okay, the spout of the gutter is designed in this manner. It's quite interesting. So the water would flow onto the ground or onto a drain, or maybe there's like a shallow pool or something, or behind this wall. I'm not sure what's behind this wall, or it might be collected into like a tank for rainwater harvesting and so on. Okay, gutter system in modern curvilinear roof, because I think nowadays, yeah, I think like students like to have, some students lah, not everyone, okay, because I think most students they like to have concrete flat roof, right? So maybe some students they want to explore a different kind of roof. They like to have even during my time. So last time I don't know why, but I like to use curved roof, like curvilinear roof in my design. So if you like to use curvilinear roof in your design, so this is how the gutter looks like. Okay, so basically here you can see like a small opening right behind between the roof and the edge of the roof, right? So basically those are the gutter. So it could be concrete, right? It could be concrete box gutter, or it could be just a normal box gutter, right? But the gutter is placed at the edge here. Okay, so maybe if you look at the building from below, you wouldn't notice this gap here. So you might think that, oh, there's no gutter inside the building. So it's not that way, right? So there should be a gutter for the building, especially in Malaysian context where we get a very high rainfall. So you need to provide gutter for your building. It's just that how you design the gutter, how you integrate the gutter design into your design. So this is the hidden box gutter, right? And then here I think more or less similar to this one, and this is like this is a valley gutter for a curvilinear roof. So this is the roof here. You can see it's curvy on this side, and then it's curvy on this side. So and then the water is channeled through the valley gutter. And actually there's between this part and this part, you can see there's a gap here, right? So this is actually a box gutter. So the box gutter collects water and then it channels to the valley gutter, right? And then I believe probably at the bottom here there's a like opening, right? That allow the water to flow into the ground, or into the drain located underground. So these are the materials for gutter. So I think I just skip this one. You can just read on your own. So this one, so I just skip. Right, now let's look at the other component, which is rainwater downpipe, or in short, we call it RWDP. A pipe that is used to direct rainwater away from a building, typically from roof guttering to a drainage system. Okay, so I've mentioned earlier. So basically, just connect the gutter to the downpipe, and from the downpipe, it would channel the stormwater to the drain. So also referred to as downspout or drain spout or roof drain pipe. Okay, so if suddenly I mention downspout, okay, so I hope you can you would know lah that it's actually referring to the same thing, which is the RWDP, rainwater downpipe. So they are most commonly found attached to the corners of a building on the building exterior. So most of the time it is placed at the corner, but as you can see from this image, it's not actually at the corner, right? So it can be anywhere actually. It can be anywhere on the building. Okay. Yeah, it depends on your design. So as an architect, you have the say where to put this rainwater downpipe. So if you don't want the pipe to actually spoil your building facade or spoil the appearance of the building, then maybe you put it on the side at the corner, so it won't spoil it wouldn't spoil the building facade. It is very important to have a sufficient rainwater downpipe in order to prevent a flood. Okay, as I mentioned earlier, actually there's a calculation method for it, but yeah, I think as a rule of thumb, not a rule of thumb, I mean as a start, probably for your design, you just need to provide more than one more than two rainwater downpipe, okay, for your design. So if not, then because if you don't have sufficient rainwater downpipe, then the water would actually build up, would accumulate in the gutter. Okay, it cannot be channeled quickly to the downpipe. Then because and in the end, the water might flood. So it would overflow from the gutter, so which defeats the purpose. If it's eaves gutter, then it's not really a problem because the water might just flow on the ground. But just imagine if you have a valley gutter, if you have a box gutter in between two roof, or in between the roof and the wall of your building, then if it floods, the water might get into the building itself. So that's why it's very important to have a sufficient rainwater downpipe. The size and number of rainwater downpipe required will depend on the intensity of rainfall. Okay, actually, like I mentioned, there's a calculation for it. So you need to know the amount of rainfall in certain area in order for you to design the gutter size and the number of rainwater downpipe. And then they typically have a diameter ranging from 50 to 150 mm, comes in round and square section and made of the same materials as the gutter. So usually when you can actually buy the rainwater downpipe component, right, at the same, from the same supplier as the gutter. Okay, because they actually supply the same. Basically, it comes in one set. So you buy the gutter and then you can buy the downpipe as well. So it is usually the same material. Typical rainwater downpipe fittings. Okay, so nothing much here. Required size here, this one, so I just skip. Right. So these are some interesting ideas of design with downspout or rainwater downpipe. So you just imagine like this is there's a roof here, and then maybe the roof is using a flat roof, or doesn't matter what kind of roof, but what I'm trying to say is, and this could be like a gutter, or I don't know, probably a building structure or something. But what I'm trying to show here is basically, instead of having just a normal rainwater downpipe, you can make it into like a design feature of your building. Okay, so this looks like a sculpture or a column or something. So as the rain, when it rains, basically water would flow, okay, through these pipes here, which is actually rainwater downpipe, collected into this this pond here, right? And then when the water overflows, or maybe the design is like that, so the water would just straight away flow to the drain here, or the channel here, and into the lake. It looks like into the lake, I'm not sure, but I think probably there's like a perimeter drain or something, or maybe there's another like shallow pool or something. So yeah, it's your design actually. You can do this kind of, you can let your imagination run wild, right? But just by incorporating this drainage system into your building. downpipe, gutter, drainage, right? So all those things can become like a design feature of your building. Okay, so you just need to have some imagination uh, to do it. And this one is quite interesting also. So instead of having just a straight, normal and boring rainwater downpipe, actually there's no, it's not wrong to have this kind of rainwater downpipe. Okay, so you can make it like this zigzag shape. Okay, because the intention, the idea of this rainwater downpipe is just to channel water from the roof to the ground. That's it. Here you can see the rainwater downpipe is discharged to like small trough. It's like a trough or a drain or something. You name it. Okay, so the water will be collected here, right, and it might overflow to the other side. But all those are incorporated into the design of the building. Okay, so yeah, I hope you can do something like this into your design. And this one, this is using rain heads. Okay, this is rain heads if you still remember. And instead of having like a normal rainwater downpipe connected to the rain heads, right? So this pipe looks, I don't know how the pipe looks exactly actually. I'm not sure whether this is like opening or something. And I don't know how the water flows through it. Yeah, but this is actually another feature. So it could be another a feature of the building. So some ideas of design with downspout or rainwater downpipe. Another example. So you can see here the first image. This is a gutter. This is not using a hidden gutter. I don't think there's a hidden gutter behind the wall, but the gutter is here. So instead of the gutter is connected right at the end of the eaves, right? The eaves of the roof. So it is placed slightly below. Okay, just to blend with this line here. So because there's a line here, so the designer or the architect wants to blend with this feature. So the architect just put the gutter right above the line, and then straight away connected to the downpipe. Okay, the downpipe comes the column, so it could be a column, but actually it's not necessary to have column. So it is actually downpipe because the column is more critical to be placed on the inside of the building. Okay, so you cannot have column here to support the building. So this is, it looks like column, but it actually is downpipe, and then the water is channeled into the ground. But overseas they tend to use a hidden drainage system. Okay, not in Malaysia. This one also the same. So this acts as a, actually this thing, this overhang does not require a column, so it can be cantilevered. But this feature, this downpipe is placed here to make it look like a column, but actually it is just a downpipe. It doesn't carry the weight of this overhang. Okay, so it just channel the water, okay, onto the ground. So here you can see like a drain, right, on the ground. And this is another example. This could be, I'm not sure whether this is really a downspout or it's just a feature of the pool or something. Okay, but you can do this actually for your as another feature of the downspout. Okay, another idea for incorporating the downspout into your design. Okay, just like the hidden gutter system. Okay, because pipes on the surface of building are not desirable because it actually sometimes it spoils your building facade. It spoils your building surface. So sometimes some designers they like to hide. They want to hide all these pipes, the rainwater down pipe or the gutter. So they want to hide everything so that it is not exposed. It's not seen from the outside. Okay, and actually as an architect, this is what you can do. This is another thing that I mentioned, that you have a control over it. So you have a control whether you want to expose it or you want to hide it. Okay, so it depends on you. So the pipes deteriorate quickly due to adverse weather condition in some areas. So last time a lot of rainwater downpipe was was built using like steel and so on. So it tends to get rusty over the years. And if you use PVC pipe, then the shape would deform after a few years. Then it would decolorize, it would deform, so things like that. So sometimes it's better to hide it so that you don't see it, and then it won't be spoiled easily. And on the other hand, they are usually not aesthetically pleasing. I think that's the strongest reason to hide the rainwater downpipe and gutters, okay, because they are not aesthetically pleasing. So I mean, if you have the chance, then perhaps you should try to hide the component. So the common method to hide the rainwater downpipe is by concealing it in reinforced concrete column during construction, or using metal column covers, or by placing the pipe behind the wall or wall cladding. So this is an example of a column inside concrete. The rainwater downpipe inside concrete column. So when the column is, when the column is casted, so the pipe, rainwater downpipe is placed inside first, then only they pour the concrete. And this one, this is like the hidden gutter system, and the gutter is here, and then there's a rainwater downpipe. And overseas, or even in Malaysia, you can use like wall cladding, so you can hide it. This is just to show what's inside, but actually this part here should be closed off with the wall cladding. But actually the rainwater downpipe is inside or behind the wall cladding. And this is the example of metal column covers. So these are columns. Okay, the column is actually just that big, right? And it is wrapped with this metal cover. And the pipe, the rainwater downpipe, can actually be placed inside here. I think, as you can see here, right? Actually, just behind the column here, there's a pipe. I believe that's the rainwater downpipe, because this is using butterfly roof. So definitely there will be a valley gutter or box gutter, right? In between this roof pitch here, and the gutter need to channel the water through the rainwater downpipe, which is located inside the casing. So this is an example of sectional drawing showing rainwater downpipe which is embedded into the reinforced concrete column. Okay, so when you work in the industry, this is a kind of drawing that you are going to produce. Okay, a working drawing. So in the working drawing, you need to have specification, you need to have dimension, and then it's quite detailed. It shows everything it describes everything that you intended for your design. Okay, not like presentation drawing where you simply design and then you don't really have to describe the material, everything. But for this one, for working drawing, yes, you need to provide the specification, the size, the material, okay, the finishes, things like that. So here you can see that this is like a flat roof or a terrace or something, and the roof terrace or something, because there's a like what do you call it, railing. Okay, there's a railing here, so most likely this is like a terrace. Okay, people can actually walk here, and like this is a drain, so a drain which is part of the concrete gutter, okay, which is made on the floor, and straight away it is connected to the downpipe, which is embedded, which is concealed inside the column. Okay, inside the column. And then on the lower level also there's a like this is like a terrace, right? So this is the wall, and this, I believe this is just like a louvers or something, not louvers like a feature, but water can actually come in from rainwater can actually come from here, and it is collected. The water will be collected on the floor, and the pipe would be connected to the rainwater downpipe. So this is like I think last week you have learned about sanitary piping. So this is just like a floor trap, but normally floor trap we use in the toilet or in the kitchen. Okay, but in this case the floor trap is used for the roof to actually collect rainwater. But the concept is more similar. It's more or less the same, and the water would eventually will be discharged to the rainwater downpipe. Okay, another component that you can actually include in the roof drainage system is the rain chains. So I think probably some of you have seen or have heard about this. Yeah, actually in Malaysia also you can actually near my house also you can see my neighbor's house using this rain chain. It's actually a decorative alternative to rainwater downpipe or the downspout, which is connected to the gutter. So instead of connecting your gutter to a rainwater downpipe, you can actually use rain chains to channel the water from the gutter to the drain, as you can see from here, this one. So the concept or the purpose is similar to rainwater downpipe, to channel water from the gutter to the ground. Okay, but this is more aesthetically pleasing. Okay, which is this is more commonly used in Japan. But the drawbacks of using rain chain is they are less steady and less high capacity than traditional downspout. Right. So in places where it rains a lot, like in Malaysia, actually it is not really suitable, because if you use rain chain, then the water might splash everywhere instead of going into the drain or flowing through the rain chain. The water might splash on the ground, right? So it might not be suitable. But I've seen in Malaysia, instead of using like a single chain like this, they use a lot of multiple chains, like maybe 10, right? So in one stripe here, there's like a 10 chains connected to the gutter. Okay, then I think it's more appropriate, no? Okay, to carry the rainwater. Okay, not suitable for places with heavy rains and high winds, especially if you have a single chain like this. If you have multiple chains, then that's fine. And then as you can see on the ground, there's a drain. It's connected to the drain, right? It's connected to the drain. Actually, this is a drain. This is a underground drain, or you can also before it gets into the drain. So maybe you can have like a vase or something, okay, to collect the water. Some ideas of design with rain chains like this one. So the rain chain is connected to the like a small like a pool or something, okay, a pond, a fish pond, I don't know, right? And here, instead of connected to a vase, so this is like a design feature, right, of the building. So the gutter, okay, the gutter is already like a design feature, and this whole thing, okay, the roof drainage is incorporated into the design of the building. Okay, and I think this is the most, I would say, unique, right? So the rain chain, these are actually rain chains. Okay, you won't believe it, but these are actually rain chains. As you can see, it is actually connected to like a gutter on the floor. So this is the upper floor. So there's a gutter on the floor, and I believe some of them are rain chains, like this one. Okay, the round ones. So these are rain chains, and some are probably just like structure supporting the things, or maybe just for aesthetic feature or something. Okay, but drain chains are actually incorporated or integrated into the building facade. And you can see actually the plants creeping, the creepers. There are creepers actually creeping up the lines. Okay, so everything is incorporated into the building facade. Okay, drain. Okay. I think we only have 10 minutes. I'm not sure if if you have time to cover everything. Okay, drain. This is just like a normal drain. So the purpose is to convey water, and there are two types of drain, surface and subsurface. And it is carried to the main drain or trunk drain or monsoon drain, and from the drainage system to the last point of collection, which is river. Okay, and property drainage shall be installed at or below ground level to maximize the interception of surface runoff. So basically, it would collect water from the pavement, right, and then from the roof it will be channeled to the drain as well. Okay, there are generally two types of drain on a building property. One is a surface drain, which carries surface water, right? The one that you normally see, and subsurface or subsoil drain, or sometimes we call them French drain, which carries subsoil water collected from the earth to lower the subsoil water table. Okay, so something like this. So this is a surface drain which is not covered. This is covered surface drain. This is subsurface drain. Okay, surface drain, also known as trench drain, channel drain, or open drain. It collects runoff from driveway. Okay, this is driveway. Building aprons. If you don't know, this is called building apron. Yards. Okay, yards, as well as from the roof through the rainwater downpipe. So basically, here you can see there's a pipe opening here, right? Which is actually coming from the downpipe. So the downpipe is hidden behind the wall, everything, and then under the apron, and the water is channeled to the perimeter drain. Okay, so you can do that in your design as well. Something like this. So you have the roof gutter, and here you can see when you have the roof gutter on the roof, you don't need to have drain below because it's going to be redundant. You already have a roof gutter, then you don't actually need. Actually, the perimeter drain doesn't have to be around the building. Okay, you can decide where to put it, but the main intention is actually to convey the water from the roof because it is already collected through the gutter and then down the downpipe here, and then from the downpipe it goes into the drain, and then from the drain it has to be channeled outside the building property. So the purpose of this open drain is actually to convey water from this building to outside. So that's why it starts here because this part is already covered by the gutter, so not necessary to have a drain over here. Okay, this is an example of a surface drain around the building, which is connected to a bigger drain on the outside of the building property. And for safety reason, you can install a drain cover, which is commonly made of precast concrete or metal grates or solid plates. And for aesthetic reason, you can have pebble filled drain cover like this. It looks like underground drainage, like I've shown earlier, but it is actually slightly different. You have a cover below, and then on top you put the pebbles, right? Sump is actually a pit at the lowest point in the drainage system, which acts as a reservoir for the sediment to settle. Because sometimes when you have a drain, because water from the yard here, it carries like a sand or particles, right, into the drain, and then the water would carry the sediment and it would be trapped into this sump here. Okay, because sump actually has like a lower, the floor of the sump is actually lower than the drain level. Okay, so the sediment will be accumulated at the bottom of the sump, and then usually it is located at the end of the surface drain. So as you can see here, this is the surface drain. It finishes here, and then from here, where does it go? So the water is connected through to the perimeter. I mean the bigger drain outside the building property through the underground piping, okay, either going here or here, or you can have some where the two open drains meet. So for example, this one, the water flows to this side, and here it flows to this side, so it meets at the sump. Okay, and then from the sump here, you can have a pipe at the bottom that channels the water to the bigger drain, which looks like something like this. So this one, so this is the pipe that connects from the sump. Okay, because this is the collector drain outside the house, outside the building. So this pipe actually connects to the sump. Something like this. Okay, you have a surface drain. This is like a porch or something. So you have surface drain. The water would flow into the sump, and then from the sump, there will be a pipe that brings the water to the collector drain outside the building. So this is a sectional detail showing the sump. And these are some example of sumps used in courtyard and subsurface drainage, which is also known as point drainage. Okay, so sometimes, especially overseas, you can see when you walk on the pavement, you can see like a small opening, like sumps. These are called point drainage. Actually, if the function is more or less like a sump, so the water would straight away flow into the opening here, and then underground there will be a pipe connect from, for example, like here, there will be a pipe connecting the sumps and into the main drainage. And here, like especially when you have a internal courtyard, right? You have internal courtyard, and you don't want to have a surface drainage around the courtyard. So this is another way how you can do it, especially if your courtyard is paved like this. So you can install sump or point drainage. So the water during the rain, water would actually flow into the sump, and then from the sump, it will be channeled outside the building into the main drainage, like this one also. Subsoil drain, a drainage system which is installed to expel excess water from the surrounding soil and building, which is needed for controlling water damage. So basically, subsoil drain cannot be used to replace, especially in Malaysia, it cannot be used to replace the surface drain because of the amount of rain that we get. So subsoil drain is not as efficient as surface drain to channel water from the building to the outside. So the purpose of this subsoil drain is mostly to carry the excess water from the ground, because if not, then maybe the ground, the yard is going to be very wet, right? And because when it's too wet, then the grass can't grow well. So you need to channel the water from the ground, okay? But not really from the building, especially in Malaysian context. Now overseas, yes, sometimes they use subsoil drain to replace surface drain, but in Malaysia, that's why you can see in Malaysia we use a lot of surface drain, okay, because of the amount of drain that we get. Okay, sump pit drainage system. This is for basement, right? So for basement, actually, especially if the basement is lower than the water table, right? So the lower than the river, the level of the river or something. So you need to have some pit, because water might flow, because you cannot channel the water outside because it's lower than the ground level, because it's basement. So you need to pump the water out. So in order for you to pump the water out of the building, you need to have this some pit. Okay, it's actually just like a sump where water flow in, the water from the whipping tile or whipping pipe, or the water from the drainage. Actually, there's a drainage inside, like this part here, drainage inside the basement. So there might be water flowing from that drainage into the sump tank, and then from the sump tank, it would be pumped onto the ground. Okay, so for bigger building, you have a bigger sump pit and some pump. For a smaller one, maybe it's just as simple as this. Like you have like just like a normal sump, and then you have a pipe and a pump, right, to pump the water out. A working drawing showing a complete property drainage system. So as an architect, this is what you're going to do when you work in the architect firm. So not just to design a nice elevation, okay, just not just to work on the planning, but you have to produce this kind of drawing in the end. Okay, your plan, you need to incorporate the drainage system. Okay, here actually you can see the drainage system is together with the sanitary and sewerage, right? The toilet, everything. You can see the main hole for the sewerage system. So all is incorporated in the plan. So for the assignment, basically, yes, we expect you to show this kind of drawing, meaning that not to this detail, but you need to show the drainage of your building. Okay, for this stormwater management part, so you need to show the drainage and how does it discharge to the main drain outside of your building property. Okay, so all right, so another one is rainwater harvesting system. Sorry, Rizal. Mr. Rizal here.
Yes, Mr. Adit.
to stop? So you want me to to continue? It's already 10 o'clock.
It's okay, you can continue. Just finish your slide.
Continue, Okay,
Yeah.
just finish, All right. Sorry, it takes too long. Wait. Sorry. Where should I go here? Okay, we almost finished with the property drainage, but we haven't covered on the minor drainage and major drainage. Yeah, actually, it's not so much on that. Okay, another that you can consider a system is rainwater harvesting system, or in short, we call it RWHS. Okay, in Malay, I think when you in the future when you do the building plan submission, they call it SPAH or system. What P? I can't remember what P. AH is air hujan lah. So I think pembetungan or I can't remember, but it is called SPAH. So which means the rainwater harvesting system. Right. So it is actually, it can be defined as direct collection of rainwater from roof and other purpose-built catchment like balcony or whatever, and the collection of sheet runoff from main mid-ground or natural surface catchment and rock catchment for portable and non-portable uses. But I think in Malaysia, it is used mainly for non-portable. Non-portable mean not for drinking or for cooking. Okay, so it's more for washing, so things like that. Okay, as you can see from this image here, so from the roof, the water is collected from the roof, from the balcony, from the flat roof, or from the surface runoff, okay, from the driveway, and so on, and it gets into the filter before it gets into the rainwater tank. So rainwater tank, and actually there's a pump lah, so it has to be, because it is located on the ground. Most of the time it is located on the ground, and sometimes it's underground, on the ground and underground. So it has to be pumped to be used into in the toilet, for example, like on the upper floor. So it has to be pumped up to the upper level. So you need to have a pump. Okay, but it is used for washing, for watering the plants, okay, for flushing, things like that. Right? Not recommended for for drinking. Okay, benefit of rainwater harvesting. There are mainly two main benefits, which is environmental benefit and economic benefit. So environmentally, it can be used as alternative water supply to supplement pipe water. So it would lower down your water bills. So instead of using fresh water every time to flush the toilet, to wash everything, to plant the trees, things like that. So you can use the harvested water. And then that one is for economically, it can reduce the water bill. Environmentally, it can reduce flash flood, prevent pollution, and things like that. Okay, types of rainwater harvesting implemented in Malaysia are backyard system, basically a system which is placed at the back of your house, at the backyard of your house. Frontage, the tank is placed at the front, which is not really, if the tank is on the ground, then it is not aesthetically pleasing. Or underground system, okay, the tank which is placed underground, which is, I think, in terms of aesthetic appearance, that would be the best to have the tank underground. So these are some examples, but of course these are for above ground tank. Okay, so this one located just behind the house. You can see from the gutter, water is collected through it's channeled into the downpipe, and then from the downpipe directly into the tank, right? And then from the tank, you need to have another pipe to supply the water back to be used. And here also same, at the back of the building. You can see actually the water from the downpipe here, it gets into like it gets into like filter system. I don't know which one is which. It gets into the filter system. I believe this is the filter, and it is pumped back to be used. So this is the pump. Same goes to this. And here, the rainwater is, I believe this is a school. Okay, this is a school building. The rainwater is collected from the gutter to the downpipe to the tank, and probably to be used for toilets at the lower level. So you can see from here, there's a pipe that goes into the toilet. Okay, I believe. And here, this is like a quite slick. This tank is quite slick, and it is placed. It is attached to the wall. So the rainwater is collected from the gutter, channeled to the tank here, rainwater harvesting tank. And I believe the toilet is just behind this wall. Okay, just behind the tank, so it can be straightway used to flush water or something, right? So these are some examples of a rainwater harvesting system. But as you can see, they are all exposed, which is not really nice to see. So as an architect, you need to know how to conceal or how to incorporate the system into your design. Okay. All right. So now let's look at the minor drainage system. Okay. So we have covered about the property drainage. So this is minor drainage system. So it is designed to collect minor flood flows from road, properties, and open space and convey them to the major drainage system. So this is like a connection between property and the major drainage, which is called minor drainage system. It consists of the street gutters and inlets, open drainage system, and stormwater pipes. So diagrammatically, you can see something like this. Yeah? So from the property, it flows to the open drain, right, or drainage pipe, just outside the building. So the one inside your building, it is called, it is also open drain. If it's open, then you can call it open drain. But like I mentioned, what differentiates them is basically the size. Okay, the size of the drain. So the one outside your house is bigger than the one inside, right? And then also from the road, it flows into the street gutter and into the inlet of the street gutter. So street gutter is this thing. Sorry, let me. Oh, sorry. Okay, street gutter is actually this thing. It's like it looks like a gutter, right, on the street, and this is the inlet. So the street gutter actually just allow the water to flow, right, beside the on the roadside and into the inlet. Okay, so you need to have inlet opening for the street gutter. If not, then there's no purpose of using street gutter. Okay, and then from the street gutter, there's a pipe connecting to the main drain, and then from the main drain, it would be channeled to the bigger drain, which is in the major system. So this part here is a minor system. So this is the drain outside your house is something like this. Outside your house and on the roadside is something like this, bigger than the one inside. So the objective of minor drainage system are to improve aesthetics. Okay, rather than having, if there's no drain, there's no minor drainage system on the roadside, then especially if the place has heavy rain like in Malaysia, right? So you can see this happen. So the water ponding on the roadside, which is not aesthetically pleasing. So that's why one of the objective is to improve aesthetic. Reduction in minor traffic accident. So how does it actually reduce traffic accident? Okay, so you can see this image here. Actually, when water builds up on the road, on the water ponds on the road, and actually when you drive very fast and you hit the puddle of water, actually your car can actually skid and cause accident. So that's why actually the main intention is to remove water, so not to allow water to accumulate on the road. So in a way, when there's no water on the road, it would prevent traffic accident. So basically that what it means, right? And then reduce health hazard. So looking at this image also, you can see that the water puddles, right? Puddles of water on the roadside. So if the water is not channeled, if not removed, then it would be a breeding ground for mosquito, fly, and everything. So it's not healthy, right? So that's why it reduces health hazard by reducing or by removing the water. Reduce personal inconvenience. So maybe if like, yeah, of course you don't like you don't like to see this thing, right? It can be smelly sometimes, okay? Or maybe if you ride a bike or if you walk on the roadside, okay, and then someone actually hit the puddle of water and it will splash on you, so you would feel inconvenient, right? So that's how it reduce personal inconvenience and reduce roadway maintenance, something like this. Okay, so if water ponds for quite a long time on the road, okay, and then it actually rains heavily. So in the end, eventually the road would deteriorate, okay, and it require maintenance. Okay, let's look at street gutters and inlets. Street gutter is actually a depression, just like a gutter that you use on the roof. Okay, just like a channel, a shallow channel that runs parallel to a road and is designed to collect rainwater that flows along the street, diverting it into a storm drain through an inlet. Okay, like this image over here. So this is street gutter, and in the end, eventually the water would be channeled through the inlet. Okay, so street gutter alleviates water build up on the street, allows pedestrians to pass without walking through puddles. Many inlets have grating to prevent people, vehicle, large objects or debris from falling into the storm drain. Something like this, you have grating, okay, cover to cover the inlet. Okay, the problem with the inlet is blockage, as you can see from this image, which is caused by accumulation of leaves, stick, garbage, and so on, carried by the rainwater. So even though the main intention or the main objective of minor drainage system is to prevent all this, right? And ideally, with minor drainage system, all these issues can be prevented. But because of this one issue, okay, blockage of the inlet, then actually the same problem would happen lah. So the water would still build up, and then during the heavy rain, right? So the water is channeled quite slowly to the drain. That's what happened in Malaysia. So from the section, you can see something like this. So this is the road level, and this is the grating, and then this is the inlet, right? So behind the inlet is something like this. It's like a sump, okay, and then from the sump, there's an underground pipe to the drain. So there's a bigger drain. Right? So this is not the drain itself. So this is just a sump, and the water from the sump will be channeled to the drain. This drain, something like this. Okay, so you can imagine this is the road. There's a gutter inlet here, and then there's a pipe, and this is the pipe actually, the underground pipe that channels the water from the road into the drain. Okay, something like that. Okay, these are 4 different type of gutter inlet. I'm not sure whether all of them are used in Malaysia. I think the most common on our Malaysian roadside is curb opening inlet. Not as nice as this. Normally the curb opening inlet is very small in Malaysia. Okay, maybe just like 1/4 of this. Okay, the size is 1/4 of this, or maybe 1/5 of this. Okay, very small. That's why it's very easy to get blocked. Okay, so that's the main issue in Malaysia. So it's not as big as this. Another example is like this combination, meaning that there's opening on the ground itself and on the side of the curb, right? So this one is just great inlet. The opening is actually just on the ground along the gutter, street gutter. So that's just opening on the gutter itself. And this one is slotted drain inlet. So I've seen this type as well. Okay, maybe not so commonly used in Malaysia, but yeah, normally in residential or in private building. So they use this kind of slotted drain inlet. So open drainage system, I think I just skipped this one. It's more or less similar to the property drainage. It's just that the size is bigger, 300 to 750 mm deep and 300 mm wide. Also known as inter-allotment drain. Okay, inter-allotment, you can say that it's between lots. So that's why you call it inter-allotment. So between building lots, so you have bigger drain, something like this. So the property drainage is inside the building. Okay, inside the building. For example, like this is a corner lot. There will be a drain somewhere here, and this is the a bigger drain outside. So the open drains in location open to pedestrian access shall be covered if the depth of the drain exceeds 0.6 meter. But I don't know why, especially in Malaysia lah. I think we can see a lot of drains in public places like public parks. They are not covered, but actually they are quite deep, right? More than 0.6 meter, I believe. So the common types of drain covering are precast reinforced concrete and metal grates and solid plates, something like this. So this is like metal. This is precast concrete, and this is metal grates or solid plates. Can't really see. Okay. Okay. Stormwater pipes. It serves as stormwater runoff and should be designed to accommodate heavy flows. Concrete pipes have been used extensively for this purpose and are normally available in sizes up to 2.5 meter in diameter. It requires access, but depends lah. For minor drainage, is smaller drains are used. So it requires access opening by means of a manhole at certain intervals to allow for access, connection points, and discharge in and change in direction points. Okay. So you can see this kind of opening, okay, that looks like some on the roadside. Okay, usually it opens up to this underground drainage pipes. Okay, now let's look at the last one, major drainage system. It is designed to convey upon collection from minor components, okay, safely to the receiving waters like lakes, river, or the sea. Okay, but in Malaysia, most likely is the river. The water will be channeled to the river. Okay, so you can see from this image, this usually happens after the rain, after a heavy rain. So the water level is actually very high. It's almost reaching, almost overflows to the road. Okay, but I think this is not bad. Okay, the worst case is actually the water overflows onto the road, which causes flood. So this is still okay. The objective of minor drainage system, sorry, this is major. There's a typo here. Major drainage system are reduce injury and loss of life, reduce disruption to normal business activities, reduce damage to infrastructure services, reduce emergency services costs, reduce flood damage, reduce loss of production, reduce clean-up costs, increase feeling of security, increase land values, improve aesthetic and recreational opportunities. Basically, these are problems or issues related to flood. So in a way, we can say that the main objective of major drainage system is to remove or to prevent flood, because flood can cause all this, okay, injury, loss of life, disruption to business activities, right? So the main objective of major drainage system is to prevent flood, to remove or to reduce all these issues. So basically, that's how it works. Consists of the following component: trunk drains, monsoon drains, and pipe networks. Like I mentioned, they are called. I mean, in Malay, we call them all longkang, right? Longkang kecil, small longkang, bigger longkang. So they are all longkang, right? Yeah, but what differentiates them are the sizes and where they are placed. Okay, but basically they are all drains. Okay, the first one is trunk drains. A trunk drain, I mentioned, is bigger than the inter-allotment drain, the drain just outside your house, bigger than that, because from the inter-allotment drain, the water is channeled to the trunk drain. So it can include culverts, road crossing, naturally occurring ponds like this one, and lakes and artificial detention or detention storage. But basically, this is detention. I'm not going to cover the detention pond, but it's actually part of stormwater management. Okay, so if the water is too much, right? Too much water, stormwater, then the water will be channeled to the detention pond, which looks like a lake. You might mistakenly think that it is a lake, but actually it's a detention pond. But the purpose is the same lah. I mean, just to store water, and then the water would be channeled slowly to the river or to the monsoon drain, something like that, right? So it is typically made of precast concrete box culvert or U-drain with sizes varies between 300 to 900 mm deep and 900 to 1.5 meter wide. Okay, so it can be quite big, no? Bigger than the interallotment drain. So monsoon drains are designed to function as storage facilities to attenuate the flood peak. With the provision of monsoon drain, an area will have adequate storage to detain storm water and to be released gradually without causing any substantial flood events. Right. So basically, from the trunk drain, the water will be channeled into the monsoon drain. Right. So in normal days or normal time, this is the water level inside the monsoon drain. So just like any other drain, it's very shallow. But when after heavy rain or during heavy rain, this is what happened in monsoon drain. So they would flood, but instead of flooding the road or flooding the ground, so the flood is contained, right, inside the monsoon drain, and it would be carried to the nearest what do you call it, receiving water. Okay, it will be carried in near the river, not directly into the river. Okay, near the river, and the storm water will be gradually released into the receiving water or river through a floodgate or flood control pump. So the water cannot be directly discharged to the river because it would carry with it, I mean, garbage, a lot of things lah. So it has to be filtered near the floodgate, and then to avoid erosion to the river banks. So that's why it has to be, the water has to be released slowly, okay, gradually. So this is how floodgate looks like. Of course, some of the images shown here, floodgate for especially for watering the, especially in plantation areas. So they need to water the plants, everything. So the one is slightly different, but the purpose is the same lah. So the one used for monsoon drain can look something like this. So you can imagine in this image here, bottom left. So the monsoon drain is actually at the back here. This is the river. Okay, this is the river. So the monsoon drain is actually at the back here. So the water, instead of directly flow into the river, it would be pumped, okay, bit by bit, slowly into the river, right? So that's why actually sometimes floods still happen. Okay, major floods still happen because of sometimes the pump also is not sufficient. It's not enough to pump the water quickly into the river. So in the end, the water will build up inside the monsoon drain. It will flood the houses, okay, because it cannot be pumped quickly into the river, right? So in that way, in that case, we need to have bigger monsoon drain, or we need to have more pumps to prevent the issue. So how a sluice or slice gate or panlock floodgate operates is basically like this thing can be lifted up. So you can imagine like the water level inside the monsoon drain is this high, okay, and slowly, because there's opening at the bottom here, so slowly the water would flow from below. Okay, just like if you have seen like a dam, okay. So the water level at the inside the dam is not dam, DAM to store water. So the water level inside the dam is very high, but then the one released into the river is actually very low. Okay, so the same goes to this. So the water will be released slowly, and depends like if let's say the water level of the monsoon drain is very high, then the door here, the gate here will be lifted higher so that more water can flow into the river. And this is the flat type floodgate. I'm not sure whether this is manual or I don't think it's manual, be automated. But yeah, water actually flows. There's a drain here. Water flows through the opening. So this one is like flap, like a book. It can be flap open, like a door. It can be flap open, there's a hinge here, so water just flow into the river. Okay, stormwater management and road tunnel or smart tunnel. Okay, this is another way to control flood. Of course, it's not related to architecture, right? But I think as an architect, you need to know about this as well. So this is a solution to flood and traffic congestion in KL. So opened in 2007. So it is 9.7 kilometer tunnel. It's the longest stormwater drainage tunnel in Southeast Asia and second longest in Asia. I believe some of you have been into this tunnel. Received the UN Habitat Scroll of Honor Award in 2011 for its innovative and unique management of stormwater and peak hour traffic. Okay, so basically there are 4 modes in smart tunnel. So the first one is without water. Okay, there's no water at all inside the tunnel. Okay, this is a normal condition. So it's just used for traffic tunnel, road tunnel. So basically there are 2 levels for the road tunnel. One is going this direction, another one is going to the other direction. Okay, and then when it rains, the water level gets higher. So mode number 2 will be activated. So water would flow at the bottom, okay, at the lowest part of the tunnel, okay, but not too much. So a car can still pass through both direction above the drain. Okay, and then when mode number 3 and number 4 is activated, then the road cannot be used, right? It will be closed. And in mode number 4, so the whole thing will be used as drainage, okay, as drainage tunnel. So maybe we can watch a video here. It's quite interesting. This is the first time I speak. Can you hear the sound?
Cannot, sir.
Cannot, huh? Wait, let me share again. Okay. Now can, right?
Yes, sir.
Okay, so the one is for flood prevention for basement car parks. Okay, so in recent years, a number of basement car parks have been flooded due to river overspilling and urban flash floods, right? Even though with all the major drainage system with the smart tunnel, everything, so it still cannot contain, sometimes it still cannot contain the water, right? The flooding. That's why the government has proposed that all basement car parks shall be provided with floodgates, right? Floodgates to prevent flooding of the car parks. So it has to be installed at the ramp going down to the basement, right? So so this is the floodgate to stop water from entering the basement. So basically, the water would just stop here, so it won't enter the basement opening. Okay, so it can it can minimize property damage, reducing cleanup and to prevent loss of life. It is also known as flood barriers or water gates and made of aluminium or composite materials. The idea is the Drainage and Irrigation Department, Malaysia, has published the guideline on flood prevention for basement car parks. There's another video to show how it works. And this will be the last part of this lecture. This is without the floodgate. So this is the proposed floodgate installation. But of course, if the flood flows, it will get to the basement. So just to show some demonstration, assuming that the flood is not overflow, then it could be prevented by using this flood barrier. There are two types of flood barrier. One is this one, automated, and one is manual. So manual one is quite tedious. So manpower needed to install the barrier. Okay, so that's all for today. Over to you, Mr. Rizal.
Thank you, Mr. Adib, for the interesting lecture. Okay. So actually, what is the activity after this lecture, Mr. Adib? Are you going to give any activities, or we're going?
I've mentioned to them earlier. It's just a tutorial to discuss about the assignment.
Okay, so what time do you want to start your tutorial?
I think my group, maybe you can start at now it's maybe 10 minutes, 10:55 or maybe 11 lah, 11 senang.
Okay, for my group, we will start at 10:50. Okay, so
Okay.
see you guys in our group channel.
Okay, bye-bye everyone.
Okay, bye.